Today we'll be covering section 7-7 on special products. This is part 1 of our two-part lesson. Today we'll be finding the square of a sum or a difference. This is Algebra Standard 10.0 and it is a KC standard, so it is on the high school exit exam as well. So let's go back a little bit to yesterday or previously when we covered FOIL. Okay, and that was the product of two binomials. Okay, so recall a problem that required FOIL, and it looked like this: product of two binomials, x plus 3 times the quantity x minus 2. Now there are many methods that you could have seen. One in particular was the box. Okay, so let's go ahead and set that up in a box. Okay. So that would be x plus 3, and we're going to go ahead and multiply it to x minus 2. Okay? So if we set this up in the box and we do our multiplication, x times x is x squared. X times a positive 3 gives us a positive 3x. X times a negative 2 is a negative 2x. And negative 2 times our 3 is a negative 6. And then we collect our like terms. We start with our highest power here, x squared, and we'll notice we have a 3x and a negative 2x. So 3x, positive 3x, minus our 2x, and our negative 6. Okay, and notice these two we can combine together. So we end up having a trinomial of x squared plus 1x minus 6. And that would be our trinomial answer for that multiplication of our two binomials. Okay, so what if we took this, and today what we're going to be focusing on is a square of a binomial. So if I took this information, okay, and I asked for today, would you be able to use what you've learned and figure out what x plus 3, the quantity of x plus 3 squared is? Now think back, what does that square really mean? That square means I have two sets of these. So really, if I were to write this out, I would get x plus 3 times another x plus 3. And if I were to set this up in my multiplication, I would get x plus 3 times another x plus 3. Let me go ahead and fill in my boxes here. X times x gives me x squared. X times a 3 gives me a positive 3x. 3 times x gives me another positive 3x. 3 times 3 gives me a positive 9. Now let's take a look. We've got x squared plus 3x plus another 3x plus 9. And if I collect my like terms together, I get x squared plus 6x plus 9. Now if you take a look, there's a reason why this is called a special product. Do you notice that in this problem, I've got 3x and another 3x. There are two of them. In fact, this is a double. We have two of them and they are identical. Okay, so we do have a shortcut. We'd like to call it a shortcut. And what we're going to do is take the exact same problem and do this another way. Okay, we'll call this our shortcut. Okay, so to shortcut this, what we're going to do is take our x plus 3, and since we know it is a binomial squared, and we notice this pattern that there's a double in that middle portion, we're going to go ahead and take this, starting at the beginning, we're going to take the first and square it. First squared would be my x squared. Okay, then I'm going to take my last portion, the positive 3x, and square that. Positive 3, and square that. Now, how do I get this 3x in the middle? Well, in fact, what it is just the x times 3, and we can see that from our table up above in our boxes. X times 3 creates this 3x, 3 times x times creates this one. So in fact, we're multiplying our x and our 3. So what we're going to do is make our little smile here. Okay, x times 3 will give us 3x. And what we're going to do is, since this is a double, we're going to multiply this times 2. Okay? What that gives us, x squared is x squared. 2 times our 3x will give us 6x positive. And 3 squared will give us our positive 9. And in fact, we do come up with the exact same answer as we had up here. Okay? So our shortcut works like this. We're going to, number 1, take the first piece, first term in our binomial, and take our first and square it. Okay? Then, second thing, we're going to take the last term in our binomial, the last, and square that. And finally, we've got to get that middle portion, which we call the middle, because it's in the middle, and we're going to double that middle. So to do that, we get 2 times the first times the last. Okay, so we take the first and last, the x and the 3, and multiply those, then we double it times 2, and that's how we get the 6x. Okay, so let's try another one. Okay, we'll call this one our actual example. Okay, example number 1. Okay, and right now we have x plus, let's say, a 3y this time, and we're going to square it. So we're going to practice. First thing, take the first and square it. So what is your x squared? We'd write x squared. What is our last term? We've got positive 3x, so we've got positive 3y, and we're going to square that. And the next piece, we are going to take our middle, which is our smile, x times 3y, so that makes 3xy, and we're going to take this whole thing times 2. Now you can put that 2 down here. I prefer to put it up here, actually, right in front. So it's 2 times 3xy, and that is positive because it's a positive 3y. So now let's simplify. X squared is x squared. Our middle, which is doubled, is now positive 6xy. And our last, positive 3y, is positive 9y squared. Okay, so now let's go ahead and give this other one a try. Okay, we're going to go ahead and give this one a try. Okay, your turn. Go ahead and try this one. If you had an x plus a 5y quantity squared. So pause here and go ahead and give it a try. Okay, so what did you get? Let's take a look. Okay, so on this one, if you did our first squared, you would have gotten x squared, which is x squared. You've gotten your last, which is a 5y, positive 5y squared, so that's 25y squared. And finally, make that smile, and you get that 5xy, which you're going to double, okay, which is times 2, so that's positive 10xy. So this would be your trinomial, okay? This trinomial, by the way, does have a special name. We call this a perfect square trinomial. And the reason that it is called a perfect square trinomial, if you take a look, it is a trinomial, which is 3 pieces, x squared plus 10xy plus 25y squared, and it was created from a perfect square. You took a binomial and squared it, so it's a perfect square trinomial, or as we like to call for short, a PST, perfect square trinomial. Okay, so let's go ahead and try one more case. Okay, one more case. What if we had a difference? So let's say you have, let's say 10 minus 3p quantity squared. Okay? We're going to do this in the same exact way that we did the other. So we're going to take the first and square it, so that would be 10 squared. take the last, which happens to be a negative 3p this time, and square it. And then don't forget that smile. 10 times a negative 3p would give us negative 30p. And remember, this is a double the middle. Okay? So then we end up with 100 minus 60p, and then a negative 3p squared would give us a positive 9p squared. Okay? And this would be your PST, or perfect square trinomial. Okay? So again, your turn. Number 2. So go ahead and give this one a try. If you had 8 minus 5p quantity squared. Go ahead and pause and give that one a try. Okay, what did you come up with? Let's try this. First squared, 8 squared. Last squared, negative 5p squared. Then take your smile, your middle. 8 times a negative 5p, which becomes a negative 40p, and double, that means times 2. So simplify, you get 64 minus 80p plus 25p squared, and that is your perfect square trinomial. Okay, so one other thing, last thing, okay, and I think this will greatly help you as you're working on these, is to start learning all of your square numbers. Okay, so in your notebook, please jot these down. Okay, and this is basically a list of all the square numbers. 1 squared, 2 squared, 3 squared, 4 squared, all the way to 25 squared. Now, I'm going to put a star on this because this is something that will be quizzed on in class. Okay? So make sure to make a list in your notebook, and we're going to go ahead and complete this together right now. Okay? 1 squared is 1. 2 squared is 4. 3 squared, everyone should know, is 9. 16. 5 squared is 25. 6 squared, 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared, 100. Okay, 11 is 121. 12 is 144. 13, 169. 14, 196. 15, 225. 16 is 256. 17 is 289. 18, 324. 19 is 361. 20, we should all know, 400. Okay, and then the last 5. 21 squared is 441. 22 squared, 484. 23 squared, 529. 24 squared, 576. And 25 squared is 625. Please make sure that you study this list and memorize it. You will need to know all of these. In addition, this would greatly help you as you're working on the squares of your binomials, okay? Because you'll never know when one of these numbers will pop up, and if you know it, you'll be faster on your feet, okay? So make sure that list is in your notebook. Okay, and finally, okay, you're going to go ahead and try these problems. Okay, on page 407, problem numbers 1, 2, 5, and 6, and bring those to class tomorrow. Okay, this is for class tomorrow. Okay, see you tomorrow.